Hello friends, and today we are going to learn, well, GoLang of course, and of course from Chris James, from his absolutely amazing repository. For those who didn't yet meet Chris James, well, here is our friend. A lot of repositories, a lot of contributions. Well done, Chris. Thank you. Now, let's do the stuff. So today we are learning structs, methods, and interfaces, right? In Go. So remember, some time ago I was very careful with even mentioning structures, even like mentioning objects and stuff, because I don't want to preach Java everywhere I go, because languages are different. So today we'll see if I swear in vain, or if GoLang actually does differ from Java in terms of objects and such. Let's see. Suppose that we need some geometry code to calculate the perimeter, blah blah blah. So that's not what is interesting. So what is interesting is this thing. So obviously we are calling a function. We're giving it some numbers and we're getting back some numbers. So that's a calculation of what? Yeah, rectangle. Yeah, okay, cool. And there's a function. Okay. That will fail, but well, this one will succeed. So oh, that's just a perimeter, yeah, because I was thinking about, well, 10 by 10 100, like how could he get 40? But let's see. Yeah, sorry about that. I'm still not well enough, but well, I will prevail. We all will prevail, because we are friends and because we are together. Now let's see. Notice the new format string. The f is for our float 64, and the dot 2 means print 2 decimal places. So let's see. Try to run the test. Write the minimal amount, blah blah blah. That's all interesting. You see how much faster it is if you read code first? So that's the first test. So, and that's the second test. This one tests area. Yeah, that's the one I was talking about, so I just didn't know how to call it in English. Well, I can translate it from English to other languages maybe. But, well, I understand the meaning of English word, but I could not, like, it didn't came to my mind fast enough that it's area. So code is like that. That's alright. Now we're refactoring, because obviously we are not using the fact that it's rectangular, right? So, and also like the data is all around the place, so like width and height and well, they're separate here, so it's like just numbers, tell us nothing, just numbers. So I think now Chris will edit some structure. Yeah, so that's the structure. Now we're testing it as so now what we are doing here, we are creating a rectangle structure, and either Chris creates, but well, I think Chris is fine with that. Now if we got perimeter, and from perimeter we so now we fit a rectangle to the perimeter, so not 1010 as it was before, but the whole rectangle. So that's fine. Let's open Visual Studio just like well, why not? So reading is cool because I don't want to code this stuff because like really, but at the same time, I don't really want to, just read the tutorial, because without practice, it's not nice. That's not how you do it. So yeah, so this one has passed. Right, so here, if we go to this one, so we can actually even read from here, to be honest. That's perimeter, that's the area that we've seen. That's the one we've just checked. So we are creating a structure called rectangle, and the point of the structure is, well, you just organize data which belongs together, you just organize together. It's a little bit like Java objects, but I wouldn't call it an object. I would call it a structure. I'm not sure yet what is the difference, but I'm sure there is. So you can Google like structure versus objects, see how it all works. Like for example, it might come that in GoLang, it might be, I'm not sure, but it might be that in GoLang there is no inheritance, and they might be replacing inheritance, well, not replacing, but well, you still have to combine different structures together somehow. So I think they might be using composition, for example, for this stuff. Don't be afraid if it's new to you. The idea, it's not as hard as it sounds. You'll understand it when you see it, and you'll see it when you are ready to see it and when you need it. So because the whole idea, we just grow here organically, and that's it. So let's see, perimeter, rectangle, float. You know what, friends? Today we'll just do, I think, structs, because method interfaces we'll do later probably, or probably not, we'll see. Because actually we've already done like 1/3. So now we can access the fields, so that's cool. That's easy, because here, you see, this rectangle, that's actually interesting, because like in Java it would come second, but here the structure type comes second, but this comes first. I think I cannot even like do this thing. No. I like Go. It makes like, if you compare it to, let's say, Groovy or Gradle, such, where the problem with Gradle, one of many, although it's an absolutely amazing tool, the problem with Gradle and Groovy, that there's so many ways to do the same thing. It makes it very flexible, but a little bit flimsy, I would say, and hard to learn. Well, for me it's hard, but Gradle, they offer amazing, absolutely amazing free courses. So like, you definitely should, if you're into Java and JVM and this stuff, then you definitely should take a look at Gradle website, especially their courses. Now, let me see. So version 4. So yeah, so we pass this structure, and now this stuff belongs together. So imagine it's not a rectangle, imagine it's a star with, I don't know, 60 dots, and imagine how much data we will need. So you can configure it once, and then you just pass this, you can just pass this star or whatever it is. Now, or imagine like, I don't know, athlete, right? So the person who does sports, and this person has so many parameters, and instead of like repeating every field every time, well, you just create it once, and it gives so many benefits actually. But let's continue, because otherwise I'm talking too much, and I am aware that you don't have that much time, and I absolutely appreciate your presence here and watching this tutorial. Please like and comment and share. And if you don't like anything there, if like something is wrong, just let me know. Like, but I'm not touching those toys there. It's my son's toys, and what's left after the divorce. So, wow. Life is life. Life happens. Now let's see. So here we run the test for rectangles, and we create this rectangle. We set the data there, and we check the area. That's fine. And now we create another structure, and we check area for this one, and that will be interesting because now we can, I think, what Chris is doing. So now he will have two more perimeter and areas, but this time they will be for different types of structure. So I think in Java it was called overloading, method overloading, when you have a method with the same name but with the different types as attributes, and when you provided enough information for the compiler to understand which one to choose, well, compiler picked the right one. No, well, not exactly the compiler. I think it compiled, and then during the runtime, obviously it was choosing the right method depending on the type of the data incoming. Yeah. Now, that's what I remember from Java, but, well, I don't code much. My job is mostly thinking and talking to people and organizing stuff. But Java is a nice language. Now let's continue and let's focus. Sorry, my autism doesn't really help to focus. So yeah, that's cool. So you see, so when he run it there, I think maybe this one. So at first they got it broken, but I think here it's fixed, and you'll see how. So here he defined so that's a rectangle structure. I think there should be circle structure somewhere. Yeah, here it is. And you see we have area function for circle and area function for rectangle, and they're quite similar except the math, okay, of course. And you see it's quite interesting how Philip structures it. So like, probably that's wrong, but my first thought will be to put all the structures together and all the functions, but maybe that's actually, I think Chris codes much cleaner than I do. Well, at least I like it. So structure is close to the functions which belong to the structure. So rectangle is close to perimeter and area for rectangle, and circle is close to area for circle. That's quite a good approach. Let's see further what happens next. Oh, and also I need to check my settings. Just, yeah, well, it works. Anyway, don't worry. Sorry, it was about stream quality and stuff. Now, hopefully quality is good enough, but, well, I still have to set up camera and learn how to connect the proper one and stuff like that, but it will take time, friends. It will take time. Just bear with me. Now, let's see. So that's interesting. Oh, okay. That's interesting. isn't that what's happening here? Now he says that it doesn't work, but excuse me. So he says that we need to add methods. Oh, I didn't notice that. So apparently you cannot do that, right? So there is no public method called area which would be holding the circle calculation. So the circle is a method. It's not actually even a function, it's a method. Why? Because you see this one. So let me just fix this what I've broken. Yeah, I've almost missed it. Well done, Chris. So you see here we are calling function and we are giving function the structure, right? And that's all good, but the problem is that we can have only one area this way. As soon as we create two of them, then well it will stop working. Alright, so like even if I don't net, I think I don't know, let's say I do that, right? It says that area redeclared. You see, you cannot declare area twice if it's a function. However, if area goes after this brackets, you see here it comes when it's a function name comes first, and then come the attribute and the return type. But here in the method we have attributes first. So if we have like circle area and let me show you two areas, right? So the right part looks similar, but the left part, well, except this of course, the attributes part comes first and it's very obvious, or second after func, but like you can clearly see the stuff, right? And that's not all. Now instead of providing giving a circle to the area, we're actually calling, it looks like we're calling a method. So like circle, tell me your area, and that's actually this one. So it's like this thing doesn't have any attributes, so that's probably a method, the method, and this is the structure which we are calling this method upon. All right, so I think that's how we should think of it. So for example, this one, this is the method, no attributes whatsoever. Well, we can try it. Example, this one, right? If that's legal. Oh, okay. So this one we can do for 64. Right, so we could give some attributes to area, but not structure. So structure, when you want to have more than one area, then you have to make them methods, and well, I hope it helps. But yeah, so feel free to open this project and check a method description, because probably you understand it, well, not probably, I guarantee you to understand it differently. And this is beautiful. We need this kind of diversity, because without diversity even pair programming doesn't work like at all, because two developers who are absolutely same in terms of sex, gender, skin color, whatever, anything, in terms of, let's say, social status, tiredness, they won't really be helping each other. If everything is the same, it's this very developer, you just have one person working for two salaries and not being, well, it could be when these two absolutely same developers could have been doing different tasks, so it's an efficient moment. When you're doing pair programming, you need to be careful, really careful. Otherwise, your company will stop doing it, because it won't give bang for buck. Now, so we're almost done second. So a method is a function with a receiver. So this is a method, this is function, this is receiver. Easy. Well, at least it gives some way to understand it. So yeah, so you can call functions whatever you like, but methods you can call only on things. Now, so that's done. That's done. That's version 4. Oh, what is in version 5? So now he added this method area for rectangle as well. So this is function and this is recipient, right? So, oh, sorry for this thing. I don't know why it's making this sound. Well, let's continue. Now, the syntax for declaring methods is almost the same as functions, and that's because they're so similar. Really? Yeah. The only difference is the syntax of method receiver. So we have, yeah, because receiver is coming here and here. When your method is called on a variable of that type, you get your reference to its data via the receiver name variable. In many other programming languages, this is done implicitly and you access the receiver via this. It is a convention in Go to have the receiver variable be the first letter of the type. Yeah, the receiver variable. But I think it's also a convention for, if you go here, right? And we go here. Oh, that's rectangle, that's not interesting, but yeah, so both receiver and attributes for a function, they come before the receiver name, and attribute name, they come before the type. Okay. Now, okay, that's done. So that's rectangle, that's method for rectangle, that's method for circle. Cool. Now he's refactoring because, well, because of that, because this piece of code is similar in terms of well, really, let's see what exactly is similar here. So, oh, sorry guys, sorry friends, I mean, I'm a bit sleepy, or maybe not a bit, but well, we'll just finish that because there's not that much to finish. So what exactly is he refactoring? These interfaces, right? So he wants to write check area. Oh, yeah, so now he's creating a function called, well, not a function, I think he calls it an interface, but let's check. Here in this one we had this got and want, right? So we had those numbers, so we will get a rectangle structure, and then we'll calculate perimeter, and then we'll say how much we want, and then only then we'll compare it. But it can be done this way, so we are giving it a test and we are giving it a shape, and dragging is what we want. And then we call area, but so apparently shape is an interface. It will be really interesting to see how the shape is declared. Let's see how it's all done. So that's the interface, right? How does it work? One moment. That's interesting. So shape is an interface which declares area, right? Okay. And what is the connection between shape and this stuff? I don't see much connections. Let's see. So shape is here, that's cool. And we call area from shape. That's also good, but like, does it work? It does work. So how does it work? Let's see. So shape is implemented by anything that can tell us its area. Oh, so because because triangle receiver can tell us area, it's considered to implement shape, and because rectangle can tell us because this circle can tell us its area as well, it's considered that circle is also implementing this interface. Well, because of that, because this one equals this one, or yeah, you see I selected, so that means that this method, the one for rectangle, implements shape interface, and this method, the one for circle, implements shape interface. Therefore both rectangle and circle I see by Go as shapes. Therefore we can write a method which is uniform for shape, which will get the area of shape, any shape, and then it will compare got and want, and it says what we want, and we get what we need, the area from the shape, and then we compare them, and it's done. That's interesting. That's very organic. I was afraid that, well, I really thought that interfaces will be a second lesson, like next lesson, but now I see why Chris put them together in the same file. It's interesting. So we are creating a helper function like we have in other exercises, but this time we are asking for a shape to be passed. Oh, somebody is sleepy. Okay, so yeah, that's okay. So yep, that's good. So a string is not a shape because it doesn't have area methods. If string had area method with no attributes, then string would be a shape as well. But well, it is not. Now the coupling. So the topic for today was structures, methods, and interfaces. We've done that. So now it's more like refactoring. Well, it's been refactoring before as well, but now Chris concentrates more on the refactoring. Table-driven tests. Oh, that's interesting. In Java, the libraries, external libraries, which we use for table-driven tests, like Cucumber or Cucumber, I'm not sure what is the correct form in English, British English or American English. So now let's see, because we've already seen that the tool for measuring performance was is built in into Go. Sorry, I forgot how to name those tools. And I wouldn't be surprised if BDD development was also part of the Go language. That would be quite interesting. Don't you think so? Now, let's see. Table-driven tests are useful when you want to build a list of test cases that can be tested in the same manner. Interesting, exciting. Now, so we have this test area, right? Yeah, so that's a function, test function, right? And here we are giving a structure, area tests. How does it work? So we have declared the structure, array O. So we said that there is an array of structures of this form, right? The structures where the shape will be, structures which consist of shape and which consists of what we want for it. And that's actually interesting because I didn't notice it, but in structures, right? Where was the first time I mentioned structures here? Oh, no. Struct, right? So you see, there's no comma here. It's just enter. This is beautiful. I didn't notice it. Like, let's actually write about it. So, well, we have brackets for a reason, but this thing is just beautiful. It's bonjour, like 1 comma less, and that's awesome. That's beautiful, and that's so big actually. So let's write a small. Let's actually take this thing as a screenshot. Well, I want like people to be able to navigate it as well. Control Shift B. We're doing this way. Yeah. Okay. Now we save it as a picture. Okay. And now we upload the picture. Let me see. Because it was a picture and not a downloaded picture, it is in this folder. Now let's do it together. How can you writing or making programming a programming language is making programming language beautiful, possible. Well, it looks, it is, well, it is in Python. We use less brackets. No, this one is about Go. Let's do, for example, in Go structures, you might, for example, because I don't know, like maybe in the future sometimes we have to use commas, but like, to be honest, I will even open this thing and I will check here, right? We'll take a structure like this one, we'll put a comma. Yeah, it complains, right? So so I can do that, but it will be excessive. So yeah, that is excessive. So the code below does
not use or commas or semicolons, I think it's called semicolon, for separation of the just struct name, field names, and types, and data types. Okay, the beauty of Go. Okay, so it's GoLang beauty. Okay, so we are checking how many symbols, that's fine. So we can afford a comma, and we can afford a small smiley. Why not? Is making programming language a beautiful one. Is it possible to create a does beauty exist in programming languages? It does. Okay. The code below does not use comma, semicolon, just a struct name, field names, and data. And it might look small, but when you are trying to focus, especially if you're tired, everything which does not distract you from the task at hand, it's a good investment. So, like, friends, whenever you can help somebody this way, well, do so. Because the thing with the code is that people read code much more often than they write it. Let me explain. So, for example, even this piece of code, it was written once, right? Now it works, but we've read it so many times. Well, now I need to like send Instagram thing, so it's immediately shared, right? And we are going to, probably if my publication tools were a bit more expensive, then I would be able to do it without the phone, but for now, it will be this way. Okay, so please bear with me, because I really prefer to like get things done, because when it's done I don't need to come back for this thing. And yeah, okay, I think I've done it, and let me see. Yeah, it does exist. And yeah, I even got a like from somebody, but well, for something else. Well, not for something else. All I do on my Instagram is helping people. And well, let's see. Oh, and also there's a friend who has a relative who is a designer, and she lost a job. So just to help, and well, we'll try to do it the open source way, right? Sorry about that. And so you might expect that soon I will book one more session for open source, and then I will try to help designers. So let's see. Let me think, where were we? Yeah, you see, I switched to helping a person, which is a very honorary and a good thing all around, but I've lost the focus. And now you, my friends, are suffering because I lost the focus. That's not nice at all. Let's pin this so I can use it every time we need it. Now, and let's actually pin this as well. Now, let's see. So, we use rectangle, so that's all right. Oh, that's, of course, that's we need interface
we've been here decoupling. So we create an array of tests actually, like, well, it's not array of tests, it's array of data for tests. So we create array which is full of structures with shape and the expected result. And what we do now, we call the for loop. This is beautiful because like I can, Chris can put, or I can put like 50 more things here, like let's do it actually, and they will be running for loop and the results will be, well, there. So I'll show it now. So I think it was probably, yeah, it's this one. So let's do more. Let's do more. Oh, you see this one? So I think, oh, so that's another beauty of GoLang. So now you don't need to like, you know, I already did the line here, and if it was last one, I would have to remove it in many languages, but here we can just keep adding this stuff, right? So rectangle 2 by 3 is 6, right? Rectangle 5 by 5 is 25. And rectangle 3 by 6 is 18, right? Right or wrong? We save it, we run it. Sorry. But did you notice it? I just copied one line 3 times. I didn't copy like here. Here, if I wanted to achieve the same thing, I would have copied this thing 3 times and I would have called it differently, because this one is, to be honest, it's not test perimeter, right? This one is test rectangle perimeter. And that's not nice. This one tests area, and then this is slightly better, right? But this tests area, and then we have to like call a method called check area on different things, on different structures. But here we just create structures, so he decoupled it. So he put structures creation in one place and actually checking if the data from the structure provides the correct answer, which is here. So here he's getting the answer. So for example, if we change data here now, oh sorry friends, like that, right? And if we run it again, oh sorry again, it will fail because that was, yeah, you see, and that's line 33. So obviously it breaks here, but well, there's some limitations, but one of them has broken, right? So probably you can write in, I think there was a way to make it even better. I think in one of our previous times we explained how this thing can be taken out and something done to it, but I don't remember. So maybe here, no, not even in the 8th, I think, right? Probably not even in the 8th, no. Anyway, that's good. So that's not something I remember. Oh, it was a helper function, right? It was called a helper function. So in GoLang, I think GoLang helper functions, right? Generic helper function. So here it works fine. So that's actually exactly our problem. Okay, so helper, right? Test helper functions, that's the one we need. Okay, Reddit, can you help me? Any code snippets? Okay, this one. Oh, there was some line there, right? There was a line which told it that we shouldn't be there was a line which you need to add to the test. So testing knows that it's a helping one, right? What about this one? What about this one? Yeah, you see? So if I took this thing out, right? Refactor extract function, right? Oh, maybe it's not a good decision. Maybe it's not very GoLang, right? Oh, where are we? So we are in, let's say, version 7, right? Oh, that's the first time I see that when you extract a function, this one, it actually fails named and unnamed parameters syntax. Well, like right. So that was what this person did, but I don't really know this thing. So this is obviously named, and this is struct. Oh, of course. You see, the problem is that here we don't really. Can I do helper here? Oh, actually, that's not the code we changed, right? The code we changed was here. And the question is, so I cannot really remove this one. Why? Because this structure is defined here, right? So the array itself is defined here. So if it was outside of the method, then yeah, we could do that, but it's not. So if at least we declared the slice, if the slice was created here, then we could do what I was showing, but well, I don't really want to spend time on that right now. Let me know in the comments if you want this to be more explicit and you want the test to show the line in the table where the problem was, the error has happened. Now let's see here. Now here, let's see. We are quite close to the end. That's good. Not bad for the day. Thank you for your everlasting support, friends. Thank you. Like really. I really appreciate it. No. Now I know what to answer to my friend designer. Let's see. So table-driven tests, that we've done. Now that's all they call the anonymous structure. Yeah, that's the beauty. So you see, the structure has no name. That's beautiful. So yeah. Yeah, so table structure is cool in the tests, but make sure that you actually need it, because like in my test I didn't actually need it. Why? Because here we already know that rectangle works, right? So I don't need to check all the
millions of combinations. It's not a corner case, right? It's not a corner case. If it was like 0, 0, then well, cool. If it was like maximum of int or whatever, then maybe if you had reasons, but you don't need to create too many tests. Too many tests is bad. You change your methods and then you have to change all the, well, the method becomes obsolete for some reason, right? You change the calculation, now it's doing something else. And if you didn't test, basically if reality changes and your tests were designed poorly, people will just delete them or ignore them, which is even worse. Because if they delete, at least they will be running tests which are normal, but if they ignore them, the languages which are allowed to ignore tests, oof, that will be bad. They might, like, I'm not sure if it's possible in Go, but probably they can just add some code there which will stop tests from being run. We have poisoned the project with bad tests for something which is not important, and now the tests which we're checking, I don't know, performance, benchmarking, yeah, that's the word for performance tests. Now benchmarking tests are not being run. So table driven tests. Now yeah, write the test first. That's called test driven development. So here Chris adds triangle first, and then when he tries to run it, we can reproduce it here. So here he already has triangle right here. So if it was commented out, I don't know how to do it here, but like if he tried to run this one, it will tell him that it's not aware of the triangle. Compilation failed. So in order to Control Shift E, right? Control Shift E and this thing. In order for the test for the triangle to run, we need to the triangle method to actually exist, or another way to call it, I think it was receiver, the receiver triangle. We need triangle receiver to have area method. That's beautiful. Now that's good. That's good. Well, so if you create this one, it will still be breaking, right? So we fixed one error, right? So basically he did that, right? He did that. So now if he runs this thing again, right? Now it will fail with a different error. Before it was failing at compilation time, but now it fails at runtime. Well, as long as it's called runtime in GoLang, I have no idea what it's called. So I'm making an assumption that it's called runtime, but well, I'm not sure how safe this assumption is. In the end of the day, I'm just an imposter. We are all imposters in one thing or another. So, well, at least I'm enjoying it. I'm accepting it. So, and so do you. I hope you're enjoying me being an imposter with a GoLang thing and so on. Now, let's see. Now. Let's really see. Oh, one moment. I need to open my recording stuff. Yes, good. Oh, and thank you for, I think it's Intercom, right? Who created this amazing t-shirt. They're cool. Yeah, they're good. Yeah, I'll actually thank them. Yeah. Oh. No. Let's see. Let's see. do some improvement. Okay. So this is the structure, right? No, this is the test. So this rectangle, that's area, right? So here what he did, he factored into the this thing, and oh, so in the tests you can optionally name the fields. So here, so this thing is optional, you see, so we can have it like this, probably, and no, not exactly like this. So moment, we'll take it from here. So and over here. So he said that the structure will have name and shape, which is similar to, oh, so before we had a shape, but we didn't have a name. Now we have a name, and so we have a shape which exists there, so like a circle, and we have a name, and we have his area. So then we are telling that it's actually a rectangle, and that's a rectangle of shape rectangle, and that must have area of this thing. So that's so we are creating a structure of a structure. So here anonymous structure had just shape and this thing, and then here we had to, oh, what's that actually? How do we explain this thing? Here we had to declare a new structure called rectangle, right? But actually the difference between this one and this one is, well, that's two different shapes. And here we can declare them separately. Yeah, that's quite nice actually. Well, I'm trying to. This is beautiful. So in this one, so yeah, I'm a bit struggling now because, well, I'm an imposter and I'm tired and I'm autistic. So hopefully it will be easier for you. But if not, it's fine. Well, we'll enjoy it together. So we had anonymous structure here as well. Here we supplied only the shape, and we supplied the expected value, right? And the problem here is that when we got it, so how do you then say that this is a rectangle? By looking at the name of the structure here, right? But here we understand that this is a rectangle by looking here. We look at the line and we can see that it's named rectangle. So for example, we could have two rectangles, like big and small. So then you could have, like, let's actually make it like, if you wanted a big and small rectangle, you can do this one, just rectangle and huge rectangle, right? And this one would be that, right? And that will be, I think it's right net. So now we have a huge rectangle here. So how do you do if you had to change the structure name? So basically we don't need, now we can change element name in the structure of the data for tests, In the table structure, we can change it independently from the structure name. This is test name, kind of like, well, it's an attribute in the test in the data for the test, but we can change this attribute independently from this one, so it's decoupled as well. That's nice. Oh, you see, it's a really nice book by Ken Beck. Yeah, test-driven development by example. That's nice. I want it. Now let's see. Now, yeah, actually I really like this t-shirt. I need to thank our friends from Intercom. Now, that's one of my most favorite t-shirts, especially when it was new. It looked so nice. Wow. Time. It can damage even t-shirts. Now let's see. Yeah, so make sure that tests must be useful. Oh, you see? So I was thinking that this should be fixed by remember we had this thing here. We had rectangle. We had test for rectangle, which is fine. And let's say we have 2 by 2 case, right? Or even 1 by 1. Oh, 0 by 0, right? Corner case, right? And let's say we thought it's 1. So when we run it, obviously it will be wrong. Well, hopefully. So it fails, but we have no idea where it failed, right? So my idea was to take this out and to make it help a function, and that will require me to take this structure out because the helper function needs to be aware of the structure. And then, oh my god, and then all the hell opens looks because this structure doesn't have to be here because it's only used by this test, and the code becomes a bit, well, dirty and not nice at all. But because now basically we have test name here, right? So what can happen is that when it fails, you can have you can be using this tt name thing, right? And you can use so shape God has area, and currently it's it feels like that, but he could let me see. Oh, so this format here, this one, you see, this one should type the whole structure. How does you say? Will print out struct with values in its field. So this thing tells me exactly what failed. So it's not even about the name. Name can be whatever name. So this name is just for our convenience. What is actually happening here is that it tells the structure which is failing. That's even more useful. I don't really need to know maybe like even which line is failing, right? So this one is saying 34, which is here. I don't need that. I need to know which data is failing in this case. Good, this is so different from Java. I'm not saying it's better or worse, but it's different, and that's beautiful. I can feel how my brain like starts becoming smarter. Well, so there's still hope. There's still hope, but I'm not renaming our beautiful website. Nope.
Now, let's see. Name the test cases that we had. So he said TRAM. What's that? Oh. And what does it change? So when we run tests, oh. So not only that, here when tests run, let's say we damage this one, right? No, let's say we do that and we damage second one, and we call the rectangle 2, and we call it, yeah. So so here when we run test, because this is testing, so that's the method from here, so the test can be run with a name as well, so right, it's not just you have different options basically for, I'm not sure how to show call hierarchy or whatever. Yeah, I'm not yet sure, but what I am sure that is when we call this, if it fails now, it will tell us, yeah, you see this one. So that's because we added the TT name here. We can rename it, we can remove it, and then it's calling different function, and it just says that v8 test, that shapes test go has failed, right? So I think that when we are calling this one, it will actually call, so it will still get a test name, right? But it will use this test name to call, well, it's probably will use it further down the string. Anyway, so yeah, it's I don't want to speculate, but what I know is that when you do that, it's a different method, right? That's 1460 and and 1460, right? We remember it. And this is, oh, this is also 1004. What? How does it work? Oh, so that's interesting. Does it mean that when I'm calling with a non-existing parameter, oh, so yeah, I don't really know how this stuff works. All right, I don't know. When I know, I know. I don't want to spend, I don't know, like, you know, I could go to Stack Overflow and write it, but how do it help me to achieve anything? My focus today is to finish this amazing lesson. Well, amazing tutorial. I hope the lesson is more or less amazing as well, and that's it. I'm probably, I would even, well, I won't lie to you, I don't want to go there and check, because maybe because I'm autistic, but making something which doesn't bring value, it's very problematic for me, which doesn't bring value and I don't enjoy it. So currently I'm enjoying the process, like really. I'm almost happy, and I've been happy like maybe a few times in my life since I was 4 years old. Basically, I don't think I've been very happy since I lost my grandparents, but ever. But maybe, yeah, not many times. But I'm almost happy at the moment because I'm helping people openly, and I'm helping myself openly, so everybody wins, and I don't judge for it. So good. So yeah, that was more TDD. We declared structs, we declared interfaces. Oh, it's called parametric polymorphism, who could say? We add methods, pardon me. We add methods, test net times, and table event tests. It's good. So yeah, types were cool, interfaces are cool. Yeah. So there's a pack of interfaces from the standard library which I used a lot, and this is beautiful. Well, thank you very much, friends. Like, without you I wouldn't have done that. So this is amazing, and you're amazing, and I know I call it Impostor Learns IT, but if it's an imposter, let it be called imposter, but this is beautiful. That's a very efficient imposter. So, well, thank you for inspiring me, friends, and please just let us be us, and that's all, and let us work together and share openly when we can, and let's all together make this world a better place to live. Thank you, friends, and see you next time, and live long and prosper. Thank you. Bye. Bye bye.